Hi everyone again. This is me, Anna Zharkova, and today we will talk about Kotlin Symbol Processing and Plugins, how to use them to optimize Kotlin Multiplatform command code. So let's begin. So let's discuss today about a little bit Kotlin Multiplatform. A lot of people nowadays know what is Kotlin Multiplatform at all, but it's always nice to remind everyone what is it and what is the conception of the technologies. Also, we will talk about Kotlin Symbol Processing as really interesting technology to help us to optimize Kotlin Multiplatform command code. And then we will also take a look at another technology, a Kotlin compiler plugins, and how these could be used to optimize command code in Kotlin Multiplatform application and simplify dependency injection. We will take a look at some practical sample, so it will be practical case, how to use both technologies to simplify dependency injection in the common code of Kotlin multiplatform application. So let's begin. And now, Kotlin multiplatform, it is SDK developed by JetBrains company, and it provides cross-platform code sharing experience to simplify your cross-platform development. It is not a framework; it is SDK. It is a model of your common files that you would like to share between two or more platforms, your targets that supports by your application. And this technology uses a different version of Kotlin and different version of compilers to compile and all the common code in specific libraries for every target. For example, for Android, it uses JVM to provide jar library and LLVM to provide framework for iOS. And it allows you to share the most of your file except of UI and platform specific, such as work with different sensors and etc. I mean, too much platform specific. Of course, you can specify the work with it using every cross-platform technology, but you also have to redefine something. So this is not good to use it in cross-platform because you need more time. So for every platform, Kotlin multi-platform uses its specific version of Kotlin. For example, for common main part, it uses Kotlin Common, and for Android and Java, it uses Kotlin JVM and Kotlin Native for iOS, Windows, and other desktops such as Mac OS or Linux. And for web version, you need to use Kotlin JS. So every part of the model uses its own version of Kotlin. So that means that there could be something done commonly and something that you need to provide specifically for this target. And there is also a challenge because not everything you need to put in common code will and could work same way. There is some platform specific movements and you need to specify its own redefinition in every target. One of the cases when we need to use something common and specify it for every platform differently is dependency injection. Why? When we need to provide the full experience of common code, of most sharing of your code, when you could everything, the most of your code make common and only make some kind of UI defined on your native platforms, you need to provide all the solutions in common code. This is a sample where we use a common code to define common architecture. And in this common architecture, we need to use special kind of dependency injection framework. Of course, we can use and do everything manually and provide some kind of singletons or maybe some kind of sample containers and do it without framework. But if we would like to provide really nice and complex solution, we need to use some kind of framework or library. As an example, I would like to present my solution for dependency injection. It is my library I wrote last year. And also, this library has a version that uses Kotlin Symbol Processing, and I'm working now on the version that uses compiler plugins to optimize my code. So thank you for the link on the Q&A section. So, and the slides are slowly loading. And how it works. This is a sample solution. It uses dependency injection container and sample mechanism where you define some kind of reference and registration links, and these links hold it on some kind of scopes. And when you're searching for the sample, or maybe for creation of new sample of some kind of some class of some type, you provide this type, and there is some kind of resolver that will search for you the link or the new sample of your object and provide it you as an output of this library. So simple manual solution. And every library, even Dagger, uses same mechanism under its hood. Even it uses a lot of different and nice injections. So, and here is how it could be used manually. So, basically, we provide some kind of configurator, and in this configurator, we use some kind of registration, and here we save our classes, the references to our types, with the specification of some kind of scope where it could be stored and what rules of creation it will use to provide the user the existing or new sample of this object. So when we do this manually, we need to repeat a lot of different code, that we use a lot of different boilerplate. And of course, it is a really nice place, a nice field to use some optimization. And there is a lot of different samples how it could be optimized. For example, Dagger or Hilt is a really nice and native solution for Android. But when we use it not only for Android but iOS, we cannot use Dagger or Hilt. So we need to specify something that we will create by ourselves, or maybe something existed, and also in this moment we need to optimize it. So let's take a look at two ways to optimize it. We will take a look at first approach. It will be generation command code with Kotlin Symbol Processing, and next we will compare it with Kotlin compiler plugins that will use also mechanism of annotations, but this mechanism will work mostly differently as Kotlin Symbol Processing. So let's begin from Kotlin Symbol Processing. Last year, Kotlin Symbol Processing was not stable. It was not stable before the September, when the first stable version was presented, and it was an alpha version, and there were a lot of differences between different versions, and users have to um, rewrite their applications to support all this stuff, and there were really ugly hack to make it working with iOS, and it was not ready to production, but nowadays it could be used for production, and everything is already made by this technology. So we have to we need to only to connect it and use it in the way we need in our application. So the stable version is 1.5.31 and newer. And the specification of this technology, not everyone know what is Kotlin Simple Processing is. It is an alternative technology to KAPT. And the main specification of it, it could be used with multi-platform, not only for Android. Though there is also a link and using of GVM, we can use it also in a multi-platform technology, and there is no restrictions. And with every new version, it is less and less difficulties when we use it. So this technology could be used for building lightweight Kotlin compiler plugins, but we will not use it in this purpose. And the main purpose, our goal is to create annotation processor using Kotlin Symbol Processing. So on the slide, you can see the samples of annotations I use in my library. And yes, it was inspired by Coin Playground. I think they provided a really nice sample last year, and it helped a lot of people because there is a lack of documentation. And simple cases were not enough for everyone to understand how it could be used to provide a really nice experience. So they were the pioneers, I think so, who helped us a lot, and they provided us a really nice sample how it could be used in difficult cases, in the complicated cases. So there is some annotations I will use for my scopes, and also for container, and also annotation to define that I need a scan for component. Well, the slides loading. So, uh, what we will do with Kotlin Simple Processing and Annotation? The mainly there is no matter what the technology of foundation we use, and about what platform we are talking about. The main purpose of annotation processing is to analyze code and to search some cases, and then using these cases we can simplify abstractions and also generate common code for some purposes. So, and it could be really useful because it will help us to define some um, boilerplate that we need that we don't need to provide in our application. So everything will be generated without us. So how it works? Let's begin from KAPT as a beginning for Android. So KAPT uses a Kotlin code, and then it was processed and compiled with the analyzing of asynchronous tree to Java steps. So basically, we needed to provide some kind of Java steps, and then these Java steps will be analyzed and provided some kind of Java classes that we will use with our Kotlin code. And the main difficulty, not only that it's only Android solution, and it is not a good solution for um, multi-platform technology, though there were some kind of samples where people show how they generate everything for Android, and then these generated files could be compiled, packed, and used for iOS. That is not a really nice solution. It's a really a hack. So, though that solution helped me last year to provide um, the working Kotlin symbol processing sample. So, what are the disadvantages of KAPT? Um, it also take a lot of time, and there is a lot of code boilerplate at the Java steps, and we have to wait when our application will create all these steps, and when these steps will be compiled with other code. And when you use Dagger in big multi-modal application, you know that dependency the mm, of the capabilities and the performance of your PC, you could wait for a long time. So This is why people from Google created for us Kotlin Symbol Processing. The main advantage of it analyze Kotlin code without any Java steps, and this is why it is pure and faster. So there is no steps, and it could be used also with Java code, and it's compatible to Java code. So, and for people who are interested in multi-platform programming, it's another advantage. It could be used with Kotlin Multiplet. Well, I haven't tested it with Flutter, so if you would like to ask me about this, I cannot answer. So how it works? Annotation processor works this way. We need to specify some kind of provider interface, and then we need to specify some symbol processor. When we implement the symbol processor, there will be some basic methods, for example, initialization, and from different versions, it used different parameters in this method. And symbol processor provider will help us to create our processor and then register it for our system. So also we need to specify some kind of resource and put it in special folder in our application, so it will help our application to understand that we're using some kind of special provider to process our annotations. And also then take a look at our custom processor. There is a main part of it. It uses some kind of resolver, and this resolver will search for our annotation during all the files and classes, and then we can also use some kind of custom visitor that you could also visit and scan data in our classes and then generate some kind of code for us. Well, slightly slowly switching. And for this purpose, we can use and provide a custom visitor that will implement KS visitor void class. And there is sample basic declarations to visit files, classes, and files. Or we can specify something our custom and use here some kind of resolver. So, what are the base mechanism of any resolver and custom processing? There is a lot of code to prepare our logic, and we need to specify this code by ourselves. Even we will use some kind of template, there will be some problems. So not the problems, but the problems to write a lot of file and to a lot of codes and to prepare our logic to use in with our applications, or to make some kind of framework and use it with other applications. So processor read and analyze sources of your program and resources, and then uh, with having all this information, with collected information, it could be generated code, and then this generated code will be compiled together with other sources. Sounds easy. And to generate and write our code, we can specify Kotlin points to write it in easy way. Well, but there is some kind of limitation. We cannot modify existing code. I think that this is a really nice idea to modify existing code and add some methods or properties in existing files. But in Kotlin Symbol Processing, we have to generate new files, and then after this, yes, it is pre-processing, thank you. It's all this preprocessed code will be processed with our sources during the compilation time. I think that the main limitation is also that there is still be not enough documentation for different cases. Well, Let's take a look at how to create our own annotation processor, and then we will take a look how to work with compilers. Um, to work with Kotlin Symbol Processing, we need to create some kind of model that will specify as a compiler and will be used as a separated model to process our code. We will to use it with Android, we could connect Kotlin JVM plugins, and then we need to specify special kind of dependency in our Gradle to work with Symbol Processing API. So there is the same mechanism that it was with before stable version, and then there is no special tricks to work with it with multi-platform. Now we need to specify only multi-platform and IGGR library to turn into multi-platform solution, and also to correct the structure of our model. So it could be easily connected as a dependency in our common model, and then it will be used with the using of special KSP processor and specifying mm, the special kind of developer tools. And also we need to specify the path for our IDE to search for the generated code, because it still be not recognized automatically. We have to specify the path to our generated code. And um, so also we use Kotlin point, nothing new. And then how it works. So we use our special processor. It is special kind of scanners and also a generator. The processor called the scanner. The scanner search for everything uh, uh, that contains special kind of annotation, and then all this stored and collected data will be processed by our code generator. So, and then we will use we will have our generated code. So let's take a look. Here is our symbol processor provider and our symbol processor. I also specified the templates for Kotlin Symbol Processing project, so you could also use it and take it on my GitHub. So, and now let's take a look at the main part. We will use our custom scanner and resolver. I mean scanner and generator. And our scanner will use resolver, and its main function get symbol presentation. This is the main function that will search for you for all symbols annotated with special annotation with special qualified name. So, and then when you have all such um, classes, you can process it and or map it or do with them what you want. So uh, and also the same way to generate it with Kotlin Point, we will need to provide some kind of template, and in this template we will have some looks on, and on this looks we will put our data, maybe some kind of file names, or maybe some parameters or constructors, or what you want. So I'm watching for the purpose how to use it with um, dependency injection, and when you will provide your own solution, of course you will provide your own template for Kotlin Point, and also you will use it with your own case and your own data. So, and after the compilation, we will see the nice output, and also we will have generated files that, with generated content, the same content that we have to defined previously manually by our hands. So it will be generated by the application, and there will be some easy way to use it. So, and now let's take a look how to work with compilers. I hope it will be more interesting for you because more people, more and more people know how to process annotation and use it with Kotlin Symbol Processing. So here is generated solution with Kotlin Symbol Processing, and yes, and how it could be used in our code. So generated configurator will be called from some kind of our application. For example, here is my interactor in common code, and to provide the service, I have to use this long line of code, and I specify the name of my configurator, the instance. So I need to know what the configurator I use, and also its logic. And also now I need to specify the actual type of my service to use it with. So of course it's a working sample. So here's the improvement of it. And now, uh, what the challenges were met when we used Kotlin Simple Processing? Uh, the generated files not used by default. In different version, even after the stable version were released, we have to specify different path to search our files. And there were also a problem that sometimes the paths were wrong because we have to specify the target. And of course, iOS could not search for Android target. So, and also this the main problem there is not too much documentation for purpose. Every developer who provide the solution, every developer who provide new working case could be the contributor who will provide some sample for other people how we could use this technology. So we are all the contributors, and we are all the tutors for other developers. So, and now let's take a look how to work with Kotlin compiler plugins. As you remember, on the previous slides, there were a problem with Kotlin Simple Processing. The line of code that were connected to common code were too big, and also we have to know what kind of configurator we use, what the command should use. And if we don't want to search for the documentation, yes, there is a main problem of all developers. It's really hard to spend 5 minutes to read documentation. It's more interesting to spend hours to search our own solution. Well, we are not talking about the case when there is no documentation. Let's think about nice case when we work with application and our command also prepared for us, our team. I mean, nice documentation to use for developing. So um, and also there is still be a lot of boilerplate code. So let's take a look at another solution that will also help us to provide some Kotlin compilation and optimization with common code. So there is Kotlin compiler plugins. They also analyze abstract syntax tree, but they could be used to modify existing code. This sounds really nice because with Kotlin Symbol Processing, we generate a lot of code. And there is something that will modify our existing files. And no, it will be not stored in our files that we could see in our IDE, but during the compilation, it will be embedded in special places. And in these places, there will be some kind of instructions. Even there will be no store generations. So how this technology works? And there is a lot of difficulties because there is less documentation with Kotlin Simple Processing. Plugin contains from several sub-plugins, and then it contains from command line processor that could be used when we need to specify some arguments. And the main part of our plugin is special extension, and in these extensions with Kotlin will be processed our code, and then there will be added some instructions. So sub plugins and plugins are Gradle technology, and processor registrar for our components and extensions is Kotlin. Um, Also, Kotlin compiler plugins is really nice because it could be used. It could be used with Kotlin native. So it's also a multi-platform technology. So let's take a look at our plugin structure. Here is our Gradle plugin to be used for injection, and then we use our own component register, and then we need to provide two extensions to process our code to work with two kind of annotations. First one is injection transformer. It is a special kind of transformer that will add some new injections for our files, and also a lowering part of our plugin. With this part, we will provide connecting and creating configurator with stored and registered automatically our services. So with first annotation, we have to use existing configurator, and we only asking to inject our service from existing registration. But with the second one, we can also provide registration and defining container our own way. So it sounds really nice. Let's take a look how it will work. And I hope it will be interesting for you for next 15 or 20 minutes. So at first, let's specify our registration. In this part, we need to define our extensions. So, and if you will take a look at Kotlin compiler plugin under the hood, it uses a lot of instructions with IR prefix. IR is a main technology that used as a backend for our compilers, and it helps us avoid of platform specific logic and use everything common way. So with this instruction, at first we will register our first extension, and then, well, slide is loading. Well, uh, and there is our extension. Here we will specify special name um, for our annotation with defining is with as a reference of the class in plugin context. And then we will use some kind of transformer that will use our annotation. So it could be called as a transformer of our model. And our model is a class that we will analyze. So here is our cases. So there is our annotations for injection and for adding, as I announced before. Yes, I understood that it's really difficult. It was really difficult for me to define this annotation. It's really challenge. Well, let's at first automate injection. So here is what we had before. We need to know what the manager we use. Also, we need to specify the path to some container, or maybe it will be done encapsulated, and then we need to call the resolver to connect our special service using it qualified name. Why we do not use the type to specify it? When we work with manual dependency injection, or maybe some kind of dependency injection without annotations, they were calling and requesting the service with the specification type generic way. But With Kotlin IR, there will be some difficulties and problems with reflection on it. So it will be the problem with inner reflection, and it could be really struggling moments. So the better way is to use specification with keyword provided by a string. So what we need to do, we would like to use some kind of annotation, and then uh, our service will be connected manually without our work. So there is a structure of our plugin, and here we will see that we use our register, our extension, and our transformer. Let's take a look at our transformer, because we also have announced how it will be connected to our extension in previous slides. So um, now let's take a look how it works. Every transformer needs to redefine IR element transformer void with context special class. And here in special function redefine method, for example, for functions, we need to redefine visit function new methods, and then as a declaration we could process our annotation. At first we need to filter. If our declaration contains this annotation, we need to create for this special kind of new body. So we have not specified body for our service, but now we need to provide it. If there is no annotation, there will be no analyze and no be modification for our code. So let's take a look how to work with it. Yes, and we need to first provide some kind of types that we will use in our work. For example, we need to specify exact references to functions and uh, objects we will use in our code. Also for lazy function we will use to provide our service, and even for any type. So when we use the compiler, we need to provide all the links by ourselves at the beginning, and even there will be the link for our configurator. So in this part we have already created a configurator, and in this configurator there should be registered our services. So let's create our body. We need to provide lazy function and to add it automatically to our declared variable with provided inject service annotation. So we need to specify the field, and then for this field we need to specify our body. And our body also would use some kind of dispatchers, and these dispatchers will be the objects that will call the method we need to use. So in case of lazy functions, there will be also some kind of dispatchers and receivers um, in this lazy function, and even in our calling class. So it depends from the point of our calling. So to provide our lazy field, we need to specify new field, and then to add the declaration, the builder, the special kind of function with factory, and also we need to specify its parameters. It's really hard moment because it will be lambda. So, and for lambda, we need to specify that it is a local, and it's also a special kind of lambda. And also we need to create our own body for this lambda. And then after everything, we need to collect and complete it in something ready-made, and it will be some kind of expression that will use our type of our lambda and our arguments to create our object. So how it will work? So here is our function, our field, and we need to specify it uh, with a temp name, and also to specify the visibility as a private, because it will be the field under our lazy function. And then here is our function of lambda, And also we need to specify its body. So here is some moments, and also and finally we need to call this in a special kind of expression. So yes, the slide slowly works. And how it could be called. There is the main part of body. There could be not only our created lambda or something else. When you need to create body and provide body to some kind of function, you need to use declaration ir builder, and then you need to specify the block body. And also you need to specify ir return and ir call constructor if you need to create something new. In this moment, we as the most easy approach, we will call the constructor of our type. And this type could be defined and used with the function return type. So yes, there is a lot of different stuff, and it's really hard to understand. Even me, I haven't understand the quarter of I'm talking about. This was a joke. I understand a half of my talk. So and now let's see how to work with the receiver. So yes, when we create some kind of lazy field, we also create the sample of our object using this constructor. But when we're talking about the dependency injection, we will specify the resolver and resolver method and the container. And we need to call the container from the resolver using the link of the methods. Uh, to specify the right point to call the message, we need to specify the receiver and how it works. Uh, well, so here is our container and our getter function, and also our uh, link to our configured application. Um, when we call something from the inside of this class or the object, we could specify the direct getter from some method, some property, or maybe some methods. But when we call something outside, we need to provide the instance to make the easy entry point to this type. Well, and of course, we could not create the new constructor type, the constructor object when we call it from the injection, and it could be wrong to create the new object. We need to specify. We need to use a singleton, or maybe it could be called from the inside. So we need to provide the instance variable in our type, in our configurator, and then we could use this um, point as a receiver of our method. So, and there is how it works. For our field, for our created field, we will call the dispatcher. That could be used the dispatcher of our function if we call it from the inside. Or maybe it could be also the receiver of the parent class. So it is when we from uh, the inside, but from outside we need to specify the special object using its links and providing it as a created type. Even there is an instance of it, we need to specify it with a create type command and to put here some kind of maybe parameters if we need to specify something as parameters, and then uh, we we should provide the reference to our method. So and then it will be called. So here is some simple schema. Yes, simple schema. So resolve will call our configuration app, and our field will call its getter and its parent class as a receiver. Yes, it's really interesting. And now let's apply it and check. We will apply our injection annotation to our service, and when it will be compiled, here will be some kind of magic. There will be no generated code at all. You cannot find it in some build output, but there will be some kind of dex files under your build transform folder, and here you can see what they contain, all this um, content of this file. So here is a sample what was called in it. So I specified my service in my interactor, and now what I see. I see that there is the call of my service movie service, and my movie service depends from network service. So there is two objects, and they were called. Oops, what happened? Um, yes, one more time. There is some end of my talk, and uh, oh, what's going on? So while my presentation and my slides are loading, yep. Dun, 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 dun. Oh my god. Mm, yep. So let me present the end of my talk without my presentation because there is something wrong with site. So there is a DEX, and the DEX you can find that that they were called some kind of your methods that you need to create new samples of the objects. And at the end of my talk, I would like to talk without the slides how to use the lowering of injection. What is a lowering? When we use transformation, it means you have to specify something predefined, and then you will add some kind of body here. But with lowering, it works some another way. So I will try to show you my screen, and I hope it will be not ugly. So yep, one moment, and yes. So I'm switching here again, and I will share my screen, and I hope it will be. Oh no, it's not working at all. So no, I'm not. So I would like to share it again. This is my selected PDF. Oh, yes, it's error meter. So why it's not working today normally? I don't understand. Memory pressure. Maybe not my local. So yes, I will share my slides, and here will be how it could be used with lowering. What's the main difference between lowering and uh, transformation? Lowering allows you to add. When you use transformation, you need to declare some kind. Oh yes, to declare some kind of existing variable and me function, and then add something at this. But not. But with lowering, it allows you to add not existing priorly, not declared priorly methods, properties, variables to your class, and then you can use it to work with your data. For example, with lowering injection, well, I think I have to use it as a first part of my talk, or maybe I know it's magic of Kotlin Symbol Processing. They processed everything, or maybe the magic of compilers. So with the injection service lowering sample, I wanted to show you how to use uh, automatic registration when you have no declaration of your container, and how to create your container only with your annotations, defining only a scope and injection in annotations, and then it will be created. It was created a container, and everything was injected automatically. So at first it was registered in this container, and then it was injected automatically. So, and in that solution, you should also specify the common point for the method. So you need to provide some kind of declaration to know what to use. Um, and it could be only your mental declaration or documented declaration, but it will be created automatically and used automatically. And also you need to call the method that will be responsible to create everything, and to call the registration of your types before you will call these injections. So, and I will share with you the links to my presentation on Q&A session, and also the links to my samples, and you could find how to use it with injection service. So maybe, or maybe there is some kind of restrictions by Aramid because compilers is too secret information, and it's not information for everyone.
I agree. There is definitely a conspiracy afoot. Um,
Yes.
yeah, Anna, you shouldn't have gone so advanced. If you stayed more junior friendly stuff, then Army would be like, okay, this is okay. We, but yeah, no, this is. I'm sorry that that happened. I wonder if it's because, I'm not gonna take guesses. It doesn't help. But do you feel like the talk is finished? Um,
Yes, I think so. I will provide the materials for everyone, and I think that it will be more helpful to everyone to read it and to check it with the code. It will be more understandable because it's really hard information, and um, I wanted at my last section to tell that. I used two main sources of this. It was a blog of Brian, who wrote the really nice thread of articles, writing your second compiler plugin, and also there was the writing your first compiler plugin talk, and also it was a sample of Sergey Shustov how to work with lambda, because work with lambda is really tricky, and when you also uh, see the version of Brian, there is a sample method, but lambda and something hard, it's really hard. You can, and I struggled with lambda and reflection for 1 week, and there was 1 week without a sleep.
hmm. And I mean, the slides are going to be like, so if you want to, are you able to post the slides in the chat here in case anybody wants to review the
Yes,
slides?
yes, 1 moment.
Yeah.
Well, so,
At least you
uh,
got through like 99, like 95% of the presentation clean. So that's,
no, it was not 99. It was 80% or maybe 75% of my presentation. Yes, it was 88 slides of really hard information, and I think next time I need to provide it more dosed. Maybe the gods showed me that I shouldn't blow up people's brain.
And
Even my own was blown up.
all right, so folks, while Anna's getting that stuff set up, if you have any additional questions or you want to vote on the questions that are already put in the Q&A area, please do that. Then Anna can answer everything.
Well, how do I test compiler plugin? You can well, you can test it with test, or maybe you could also specify it with your compilation. You can well, you can to test some plugins. You need to specify some breakpoints and also to provide some tests where you will check if your examples were created or not, because will be created during your compilation, if, or maybe running your test. So also in the threads writing your second compiler, there were some kind of tests how to work with it. Um, any advice or tips related to performance when writing a plugin? You need to you need to think about your architecture, because there will be some kind of struggle moments, and also you need to find some ready-made solutions to work with it. um, when I struggled with lambda, I found a really nice sample for lazy field in Sergey Shustov's sample. But when I needed to provide the add-in, the code template to my configurator, where I use the lambda to create my and specify the fabric creation of my objects, when register them. So I used this lambda as a parameter. I haven't found ready-made solution, but I found it in JetBrains compilation code. So during the performance, I think that you shouldn't process a lot of files. You need to specify more short ways. Do not process everything, because when we use something just like Dagger, but also more files, more classes we use, more information we use, more time it took us to process it. Are there any guarantees for KSP AP stability or Kotlin side? I think that from the stable version, they will be stable, but every version of it will be more and more stable. And of course, there is some differences between different versions, even with paths, because in some version after 1.5.31 there were differences. For example, you could specify only path is Android debug, but not for a common point. And of course, when you common main, you can specify it as the same path for Android when you compile it for Android, but it's not suitable for iOS. So they check and fix some such samples, such problems, and so this processing will be more and more stable. I think that the main point of instability of this API, it could be connected with a new memory model, because with new version of Kotlin, I read in Slack of Kotlin community, there were struggles for different people with processing the file in newer versions. But maybe it's because of instability, not Kotlin Symbol Processing, but not released the stable version of new memory model. Can IR compiler type resolution be somehow used in KSP? For example, it's really tedious to resolve type params of function joins type with KSP. I don't want to mention parameterized interfaces resolution that doesn't come out of box. I think that they could be used together. Also, you can use Kotlin Symbol Processing to um, not the same time, but in different parts of application, because you use Kotlin Symbol Processing and you know and you get information about the annotation and the properties, functions, and classes that use this annotation, or maybe it could be commonized as annotated symbol during your compilation. And unfortunately, you also use and get information about in compiler even during the compilation. So you could use them for different purposes or maybe together. For example, you can specify Kotlin Symbol Processing as a analyze and generating mechanism for something really hard. But you could, or maybe try to use something with the Kotlin Symbol Processing and then add something with IR. Well, I think that this solution could be done, but it could be really hard to create something else because of like documentation. And I haven't understood how it could be done completely. So, but I think that it could be done.
Okay, that settles that. Anna, thank you so much for another presentation. I'm sorry, Airmeet fudged things up a little bit there. I mean, you were prepared. Airmeet clearly wasn't. Um, but yeah, I mean,
Um,
another. Go for it.
well, I think that the main point in this that I have an opportunity to join your community today, and also I will share my presentation and um, my data, but more conspired way. It will be only for those who are watching this event, and of course it could be provided in Twitter or Facebook. But at first, but the first people who will get it are the spectators and the guests of today's session.
Thank you so much. Okay.
You're welcome.
Then we're gonna head back to the tables, folks. If Adit is still around, anybody who had questions from Adit's talk, feel free to find him at some table. Maybe Adit, if you're still around, post which table you're gonna be at once you're settled in. Otherwise, yeah. All right, guys. We're taking about, I think it's a half an hour break now. Half an hour break? How long is the break? Oh, we have about a 15 to 20-minute break now. Okay, sweet. Anna, lovely seeing you. I'll see you at the tables. Bye, guys.
Bye, everyone.